Creating an Eclipse project for Luckfox. Here I have my Ubuntu operating system running inside VirtualBox. Now I will launch Eclipse. Here is my Eclipse IDE up and running, and now I will teach you how to create a new project for Luckfox embedded development environment. First, let us go to the file menu and then select a new project. From here we have various templates, and we have to go inside this C++ section, and from here we will select a C project and then click next. Now we have to provide some basic information about our project. So the first one is the project name. Let us use Luckfox test here. This will be our most basic project, and its aim will be to teach us the entire process. And from here we have to select this Hello World C project, and the most important setting here is these options, that is the option for toolchain. We have two options here. One is the Linux GCC, and this is useful when we are developing native application for our desktop operating system on which we are running this IDE. On the other hand, when we want to create a cross application, that means we want to use a cross toolchain, and we are using this as our host environment. That means this PC, this virtual box, is acting as a host or the development platform, and the platform which will actually be going to execute our application will be a different machine, and that is the reason we are calling this as a cross GCC. So just select cross GCC option here, and this will instruct Eclipse to use a cross compiler, not a native compiler. So this is a very important step when we are developing for a embedded Linux application. And here you can provide basic information about your project. That means the author name, copyright notice, everything. Just click next after filling appropriate values here. And this is the standard set. That means we will be having two configurations in our project. One is for debug and another is for release. So if you are an experienced developer, you should be knowing what are these two configurations. And now the most important setting. And these are the settings for our cross toolchain or the cross compiler. So these settings will help Eclipse locate our cross compiler. So here we can see that Eclipse is asking for two informations, and the first one is cross compiler prefix and the second one is cross compiler path. So let us open our file browser, and as you can see, I have installed the Luckfox SDK here in this subdirectory, and this is my home directory, and inside this I have a subfolder or a subdirectory Luckfox Pico. So the SDK is actually inside this subdirectory, and here you have to look for this tools subdirectory. This tools subdirectory contains the actual tool chain for this development board, that is Luckfox Pico. Let us open this folder, and here you will find two more subdirectories, one for Linux and another for Windows. The tool chain and the compiler is only available under the Linux host. So for development purpose, we cannot use a Windows based host, and this is the limitation. We have to use a Linux based host. So let us open this Linux subdirectory, and inside this we have few tools, and we have the tool chain here, and the tool chain is named something like this. They have the processor architecture in its name, like ARM-Rockchip, and also the operating system, that is Linux. And here we have the libc specification, and this toolchain is using UC libc, that means micro libc, and this last suffix, that is bih, this is GNU EAB. AB stands for application binary interface, and this HF stands for hard float. So this completely defines the platform on which this toolchain will work, or this toolchain will target this platform. Let us open this directory also, and here the interesting thing is the bin folder, and inside this you will find all the standard this GCC executables. These are the actual C and C++ compilers. But as you may be knowing that the native GCC compiler is named only GCC or G++. This GCC stands for the C compiler and G++ stands for the C++ compiler. So the native compilers, they are named in that manner. For example, if I open my terminal here and execute this command, so in this case the native GCC will run. This is the native GCC of my Ubuntu platform. So here we don't have any prefix to this command, that is GCC or G++. In these two cases, these two compilers, this C compiler and the C++ compiler, they are both native compilers. So they will output a code that will run only on this Ubuntu system, which is running on a PC platform, that is x86_64. That is a 64-bit x86 Intel CPU or compatible AMD CPU. The code generated by these natives compiler won't run in any embedded Linux board like Luckfox, which is based on ARM processor. So we have to use a cross compiler or a cross tool chain. So these cross tool chain, they also have names like this, GCC and G++, with one exception. They have a prefix added to these names. So let me close this terminal now and focus here. And also let me change the view type to a detailed list view like this. Now if we see that we have commands like G++, GCC, but they are prefixed with this platform identifier: ARM, Rockchip, Linux, UClib, GNU, EABIHF, G++, GCC, and in the same way linker also. This is the C++ linker LD. So all these commands are standard commands of this GCC package or the GNU compiler connection package, but they are prefixed with this target identifier or the platform identifier. So this help us keep multiple toolchains on our host, and each toolchain targeting a different platform, and we are free to use any of these toolchain as per the requirement. For example, when we are developing for the Rockchip, we can use this toolchain, and on the other hand, if we are using another platform like RISC-V, then we can use another toolchain. So now what we have to do, we have to go to any standard command like this GCC, and here we have to copy the prefix till this last minus sign before GCC. So just hit rename here and then copy this prefix like this and paste it here on Eclipse where it is prompting for cross compiler prefix like this. Make sure this last minus sign is there but not the actual command, that is GCC, because we only need the prefix, not the full command name. So using this prefix, Eclipse will be able to generate the full command names from the cross compiler toolchain. And the second thing, we need this path, home Luckfox, this complete path. So just right click here, go to properties, and then copy the entire path to this bin subdirectory, complete path from the beginning of the root file system, that is this first slash home slash Avinash, like this. Copy this and paste it here where it is prompting for the cross compiler path. So it should begin with this first forward slash and then home, then your username, then where you have downloaded the entire SDK, and finally up to this pin directory of the toolchain. Now let us hit the finish button, and Eclipse is creating the project for us, and here it is, the project is ready. And a new C file, that is luckfox underscore test.c file, is also added to your project by default, because we have chosen for a hello world project, not an empty project. This is good. So here is our project, that is luckfox underscore test, and by default it has our hello world code here. Now let us try compiling and building this code. So from here, choose this hammer like icon for build. See, it is compiling and building our project, and it has completed successfully without any errors or warning. And it has used our cross compiler. Now let us locate where the executable is created. And here we have our executable file, and this is arm/le, and this is the executable file. Let us also locate this file. Using the file manager. So open a new file manager window. And from here, please locate your Eclipse workspace. And my workspace is here. And inside this, we have various projects. And find the project that you created just now. That is the luckfox underscore test. And here we can find the executable that is generated by our cross compiler, and it will be inside this debug folder for debug configuration. If you change the configuration to release like this, if you go here and change the configuration, by default it is debug. If you change it to release and then rebuild the project, I have changed the build configuration to release, and if I build the code now, you will see another folder called release. So this directory will contain the release configuration of the build. So now let us first focus in the debug build. In between, in the intermediate stage, we only use the debug build. So now let us focus only in the debug build. So inside this debug build, there are several files, and this one is the executable file. This file with this gear like icon. So this is the executable file for Linux operating system. Now our task is to move this file, this executable file, to our target development board, and then only we will be able to execute this file. And since we know that this our target embedded board, it has a root file system, so we have to place this file somewhere in that root file system, then only we can execute this file. So now let us see how to do that. So the method that I am going to discuss uses the USB connection to your target. That means you have to plug your Luckfox Ultra board to your PC using a USB cable connection. And in order for the USB connection to work, you have to install the USB drivers on your Windows subsystem. You don't have to install the driver here in the Linux. You have to install the driver in your main base operating system, that is Windows. Here you have to install the USB drivers, and the USB drivers is provided by Luckfox, and all these steps are already discussed in the previous lessons. And over this USB connection, actually we run a network connection. So if in your Windows, if you go here, view network connections, you will find that a new connection is added here, and this is added by the drivers of Luckfox. And here it is here, this one. In my PC it is Ethernet 3, and it should be configured to use a static IP address like this. All these steps are also discussed in the Luckfox website. If you go to the website of Luckfox like this, luckfox.com, and from there you have to go to the wiki section, and the wiki section is here. And you will find all those steps, driver installation, driver downloads, everything here. So please refer to this documentation. I am not repeating these things here. Now let us go back. So actually what we are doing, we are using an SFTP The SFTP is a specialized form of FTP or file transfer protocol which runs over SSH. And this SSH is the basic access system to the Linux remote Linux terminals, and it stands for Secure Shell Protocol. And through this, we securely over an encrypted connection we can access any remote Linux devices, whether it is a server or a small embedded device. We can use SSH to access it remotely, and SFTP works over SSH, and it adds the features to transfer files to and from that remote Linux system. Now the great news is that this Nautilus file browser, it has inbuilt support for SFTP. Nautilus is the default file browsing program in GNOME-based Linux operating systems like Ubuntu. And you can access the SFTP features from here using the other locations area. Here in the other location, you have the option to connect to a server. And here this server is running inside our embedded development board. And it is the SSH server through which we access any remote Linux. And here Nautilus allows you to enter the IP address and then just click connect. So as I am already using this development board, I have already added this area. So here is the IP address. It is 172.32.0.93. So this is the default IP address of our development board, that is Luckfox, when you use a USB connection. So when you just double click it, it will open the root file system on our remote or the embedded system development board. So as you can see here, how easily I am able to access the root file system of my target embedded development board. These files are not stored in my this PC. These are not in the host. I am using the USB network connection, and I am viewing all this file, the root file system, all the directories and files, just like a normal file system which is present directly locally in my Ubuntu operating system. But these are actually remote files. So as you can see how easy it is to access my development board using the features provided by this Nautilus file browser. And here I have created a folder named Avinash, which is also my name, to keep all my testing project files. So just I am going inside this file, and now here I can paste the newly created executable, the executable that was created by Eclipse and our cross toolchain. So going to our build folder and copying this executable file, just right click, copy, and go to this SFTP section. So here we are inside our Luckfox, and here we can easily paste it. Now the file is here, transferred easily to our target development board. Now we are all ready to execute and test this file. Now let us see how to execute this program. For that, start putty. Here I have PUTTY SSH client. Now I have to connect with my development board over a network connection, and we will use the same IP address. So just make sure that you have selected SSH here, and here enter the IP address or the host name, and our IP address is 172.32.0.93, like this. Port is okay. Everything is okay. You can also save this configuration by some name. So it will save this IP address for later use. Now we can try connecting with this host. Use the open command. Just select accept. First time it will ask you this. Now here it is asking login as. So here enter root, and then it will prompt for the password. You can get the password from the Luckfox website, their wiki page, and it is Luckfox. This is the default password. Now we have access to the system. We have the command prompt. By default it is inside the root folder. So just change your current directory to this slash. Now we are at the root file system, the root. If we do ls, we will be able to view all the files that we were viewing using Nautilus. here. All the files will also be available. We will be able to view all the files here. Now what we have to do, we have to go inside this folder, that is Avinash. So we have to issue a command like this: change directory Avinash, like this. Now we are inside this folder. Do a ls or list. So we can see we have our executable file here. So the executable files are represented in this light green color, this bright green color. So we can see that the newly created executable file is here, Luckfox test. Now we have to execute this file. For that we have to write a command like this: dot slash dot forward slash Luckfox, the name of the executable file that you wish to run. And here you can also use the auto completion feature. You can just type a few letters of the commands or the few letter of the file name and just hit the tab key on keyboard like this. So it has auto completed this file name, and now we are all ready to hit the enter key to execute this program. Now let us see what happens. Great, we have hello world. Hello world is printed as it is here, as we have instructed in our program code in our id. So everything is working great. After a while you will feel that this copying and pasting method is too much time consuming, and you will need a method that is more streamlined. So now I will show you how Eclipse can help you with this. After all, it is an IDE and it is expected to have all the feature right in integrated in a single place. So for that we need to create a new debug configuration or new run configuration. So go to this drop down just near this bug like icon, and from this menu select debug configurations. And these types of debug or run configurations are called C++ remote applications. So here you have to create a new C++ remote application debug session or run session. For that we have a new icon here, this one. This is new launch configuration. Just hit this button and now we can create a new configuration. And the very first option is your project selection. Because we have lots of projects in our workspace, we have to choose one. So here by default this project is selected, that is Luckfox test that we have just created. And next you have to choose the executable application. So just search project, and from here you can select, and this one is the debug build and this one is the final release build. So you can choose any one of them. See, it is in under this debug folder and release. So we have two executable in this project, that is why it is prompting us to choose one of them. So for debugging, choose this one which is under the debug directory and click OK. And here is the interesting part. This is the remote connection to your embedded system, to your board. So we have to create a new connection here, uh, and you can also choose a connection from this drop down menu. As you can see, I already have created this option, so I can directly choose Luckfox Ultra USB connection from here. But I will tell you how to create a new one. So this connection also uses the SFTP protocol that I have discussed previously in this video. Just click new, and from here you can choose the connection type. You have to choose SSH, that is the secure shell protocol. And now here you can provide a name for this connection so that you can find it later, and every time you don't have to create all these entries. So let us name it something meaningful, and so let us name this something meaningful like Luckfox USB. And here you have to enter the host information, that is the IP address of your development board. I have already discussed the IP address previously in this video. Let us enter that same IP address here. So it was this IP address, that is 172.32.0.93. 172.32.0.93. Let me check it. Correct. And the user is root. Choose password based authentication and enter the password. The default password is Luckfox. and just click finish, and the new connection will be created here and it will also be saved for later use. See, we have it here. And now we can choose the path where we wish to install the newly created executable from this IDE. For that we can also browse this. So when we hit the browse button, the actual connection is established and we are able to view all the files in real time. So when I it is connecting, and now I am able to view the actual files that are present in the file system of my embedded development board. See, we are able to browse the root file system and we can choose a location where the new executable files will be installed. So let me so you can create a folder here for storing all your executable files. I have created this folder Avinash, and this is also my name, so I will choose this folder and all my executables will be stored here. Now we have to do one more important setting before we can start our debug session, and for that we have to go to this debug tab, and here we have the option for GDB. So this GDB stands for GNU debugger. So this is the part of this GCC, and this part is helpful for debugging application and it is called GDB. So by default here native GDB is selected, and this is useful only for debugging native applications for this desktop PC. We have to change this to cross GDB, and again we have to hit the browse button and go to our toolchain location. And as I have discussed previously, we have to go inside this tools folder, Linux toolchain, this one, inside the bin directory, and here we will find the cross debugger or the cross GDB. Here it is. We have to choose this one, and this will work for our platform correctly. So this GDB has two parts or two components. The first component run on the host PC and it is executable that can be run in a host PC. And the second component is the GDB server, and the GDB server runs on target. That means our embedded Linux development board or Luckfox. After properly configuring the GDB, we will move on to the GDB server setting. And this is the GDB server program. So this GDB server runs in our target, and this is native to the target, so it will not have any prefixes. So let us first confirm that whether this is installed in our target or not. Generally all embedded Linux board vendors, they generally by default install GDB server on the target board, but let us confirm this fact. Start PUTTY and connect to our Luckfox. Login. Login success. Now here type the command, same command that is written here, that is GDB server. And then request its version number. See, our GDB server is already installed in our target board. Now this GDB server will help us connect with Eclipse and perform a remote debugging on this target board. Now let us close this terminal and start the debug session. But before that, let me discuss an important point, and this is that if you don't see UI like this, options like this, then maybe a different option is selected here. In that case it will show you that using GDB manual remote launcher, but we have to use automatic remote launcher. So in that case you can switch to automatic by using this link, and it will be switched to automatic. Now we are all done and we are ready to debug these remote application in the very same way we debug a local application. There will be no noticeable differences and our development experience will be really smooth. Now see, it is connecting. Now see, we have our run pointer here on the very first executable line of the main function. So this confirms that our debugger is running and it is connected to the remote development board, and the and we are all ready to debug this program. And very interesting thing is that we also have a console allocated here, so all the outputs from our program, our remote program, will directly flow into Eclipse and will be visible here in the console. We don't have to use another putty to view those messages. We don't need this also. So this terminal feature, this remote SSH terminal feature, is also integrated inside Eclipse, making it a truly integrated development environment. Let us see what happens when we hit the resume button. To run your program, you can use this resume button, or we can also step our program using the debug menu. From here we can step our program. I will not discuss these steps as I am assuming that the user is very much familiar with debugging. I am just showing you how to debug a remote embedded Linux device using Eclipse. Let us hit resume. See, we have our text hello world printed here, and this text is coming from our remote embedded Linux device, that is Luckfox. And notice the comfort, we are using only Eclipse, we are not using any other third-party application. Everything is integrated inside it. We can simply change our program here, save the file, and with only a single click of button, everything is done. The program is built, pushed to the remote target, and a debugging session started. Just click run and see the update here. So we don't have to move to any third party application. So now we don't have to move to any third party application like file transfer or PUTTY, anything. We can do everything from inside our integrated development environment, and you cannot tell whether you are debugging a native application or a cross compiled application that is running on a different target. So the experience is really very smooth. So now let us try to understand what is happening when we are hitting the debug button. So here are the logs in the console. This is our command prompt, and in this command prompt, Eclipse, through a SSH connection, it is executing this command, that is GDB server, and then it is specifying a port number on which this GDB server will listen for incoming connections. So where we have specified this, if we go to the debug configurations and open our debug configuration, debugger, GDB server setting. So here is the option to specify the port on which, and this is the TCP IP port on which our GDB server will listen for incoming connections. So the same port number Eclipse is passing here, and it is starting GDB server on this port. And then it is specifying the program to debug, and in this case it is luckfox underscore test, which is located under this subdirectory, that is Avinash. And then the GDB server is started, and GDB server is telling that process Avinash slash luckfox test created successfully with PID, and this PID in Linux stands for process ID. So this one 1524 is the process ID for the newly created process, that is Luckfox test. And then GDB server is also notifying us that it is listening on this port, and we have to issue a connection to this port, and then Eclipse immediately issues a connection to this port, and this is done using the cross GDB command. That means this one, this program, this cross GDB, Eclipse is using this cross GDB to establish a connection to the remote GDB server, which is running in our embedded Linux target board. And then the remote debugger informs us that it has received a remote debugging session from this IP, from this host. So this is the IP address of my PC. So this remote GDB debugger is getting an incoming connection from my PC. And then we have the output from this program, and then the child exited with status code 0. This exit stands for status code 0. So that's it for this lesson. Thanks for watching. See you in the next video.